Okay, let's dive into this. Today, our explainer takes us to the absolute biological limits of living things. We're following a super intriguing ongoing logbook called Notes on Fishkeeping. Specifically, we're zooming in on part 262, written by an author named Ang. Now, Ang isn't just, passively watching fish swim around. They're running an active experiment on what happens when you push nature way past its standard operating procedure. We're going to explore the resilience of a really common aquatic plant, duckweed, and see exactly what happens when you throw it into an environment that literally never sleeps.
It's kind of wild to think about, right? Can life actually survive without darkness? I mean, we take the natural balance of day and night completely for granted. It's basically the rhythmic heartbeat of almost every single ecosystem on Earth. But what happens if we just turn that off? What happens when a living thing is completely denied the rest that usually comes when the sun goes down? Well, that is the central mystery Eng's experiment is trying to solve. We're stripping away the night and watching, in real time, how this organism handles unrelenting, nonstop energy.
To really get the stakes here, we have to look at a core biological contrast straight from the source material. On one side, we have mammals, us. Our biology is totally governed by strict circadian rhythms. If we don't get darkness, if we don't sleep, our systems break down incredibly fast. It's not pretty. But Eng decided to test the exact opposite side of this coin. What about aquatic plants? What happens if we subject duckweed to extended photoperiods? Do they have those same hard biological limits that we do? Or can they handle a reality where the sun literally never sets? 24. That's the magic number here. For the past 3 straight days, Eng has been blasting this duckweed with continuous LED cycles, 24 hours a day. 0 breaks, 0 dimming, just pure, unadulterated light for every single second. It's a super intense environment. Eng has basically turned a standard aquarium setup into this high-stakes botanical testing ground. And that brings us to the core scientific concept of our explainer today, continuous illumination. Basically, this is just the process of exposing plants to prolonged light exposure without any dark intervals. It's a very deliberate manipulation. Eng didn't just accidentally leave a desk lamp on, right? This is a highly calculated test to see exactly where the duckweed's breaking point is in an otherwise completely controlled aquatic environment.
Now, what's really interesting about this slide is the deception, because right now at day 3 of this 24-hour light cycle, the duckweed actually looks like it's flourishing. It looks like a massive success. The plant seems to be absolutely loving the endless energy. But as Eng points out from their reading, this is incredibly deceptive. It's a total biological trick. That initial burst of rapid growth, it's expected, but it is absolutely not sustainable.
Let's map this timeline out because this is where the suspense of the experiment really kicks in. At day 0, the 24-hour LEDs go on. By day 3, which is where the logbook is right now, we see that initial burst of rapid growth. The plant is just gorging on the light. But look at what comes next. Lurking out there in the unknown future is this stagnation point. And after that, the inevitable eventual outcome, the total decay of the fronds. So this whole flourishing stage we're seeing, it's just a temporary spike before the duckweed hits a massive biological brick wall. So how exactly does it hit that wall? Well, it happens in 2 very distinct steps. We're currently handing out in step 1, rapid growth. The plant is taking all that continuous illumination and converting it into rapid expansion. But step 2 is where reality is going to bite. The duckweed will hit that stagnation point, and this means the plants completely, entirely stop multiplying. Even though they have all the light and energy they could ever possibly need, the biological engine just seizes up. The growth completely shuts down. So, why does the engine seize up? This is a brilliant example of the unseen consequences of too much of a good thing. The culprit here is oxidative damage. This is the cellular harm caused by prolonged light exposure without balanced, periodic dark intervals. While the plant might look totally fine on the surface right now, down at the microscopic cellular level, the lack of darkness is slowly tearing it apart. The plant absolutely needs those dark intervals to rest and to balance out those intense chemical reactions driven by the light. Without the dark, the light literally becomes toxic. Because of that lack of balanced, periodic dark intervals and all that resulting oxidative damage, the duckweed is pretty much on a collision course with total decay. And Ang knows exactly what physical symptoms to look out for next. When that internal damage finally makes its way to the outside, it's going to show up as the yellowing of the fronds, and then eventually the browning of the fronds. That lush, bright green we saw at day 3, it's inevitably going to give way to yellow and brown as the plant's internal structure finally collapses under the weight of all that unrelenting light. Honestly, this is exactly what makes Eng's logbook so incredibly captivating. It's a live, active micro-case study. Eng perfectly captures this suspense here, writing, "I'm curious to see how many days we can maintain this prolonged exposure before the duckweed starts yellowing or browning. We'll eventually find out in the coming days or weeks. It really is just a waiting game now. The science tells us the duckweed will eventually fail, but the exact limit of its resilience, like how long it can actually hold out against the continuous light, is still a total mystery." Which brings us to the ultimate takeaway of this explainer. This entire experiment just perfectly highlights the incredibly delicate balance required for life to sustain itself. You can give an organism infinite energy, but without the time to rest, repair, and process that energy in the dark, it will inevitably destroy itself. The duckweed is flourishing today, sure, but that biological clock is ticking. How long can nature truly outrun the dark? It's a fascinating question, and one that leaves us eagerly waiting for the next update from Eng's fish room. Keep that in mind the next time you think about turning off the lights.